first job on Tower Bridge is a site analysis. LES management perform a thorough LES-specific check of the site. The check provides important information that LES needs to perform the job. The site is surveyed and primed for the commencement of work. The main focus during this part of the project is safety. A safety assessment means that the job will go smoothly and safely. Preparation is the key to any successful project, and LES are keenly aware of the need to lay down a firm route for any structure. The LES trucks must be unloaded and containers put into position. The trucks carry with them everything this job requires, from hand tools and heavy equipment to mobile office and staff tea-making facilities. Once the logistics are complete and all equipment is in place, the real work on the bridge and structure can commence with speed and with the firm assurance that everything is properly prepared. Before the task of replacing the nose bolts that join the two parts of the bridge can begin, there are many tasks to be completed, and these can be split most easily into 3 areas of work. These are the 3 parts of the bridge that were worked on in order for the job to be completed: the pawls, the resting blocks, and the nose bolts. Each area had its own method of work and individual tasks to be completed, and each job presented its unique challenges.
Tea break when that drill plate. Alright, let's get out there and have a safe day.
Before work can begin on any task, no matter how large or small, a risk assessment must be completed to fulfil LES's exacting safety standards. A permit to work must first be given to those conducting the job. This allows management to be sure of exactly who is doing which task. On such a challenging job, this is of paramount importance. The team install all the necessary safety equipment to allow the skilled craftsmen to work in a safe environment. This includes the installation of safety handrails and the connection of inertia reels in case of a fall, a very real possibility when working underneath the bridge. Suitable PPE equipment must be worn by craftsmen at all times. The old resting blocks, which are used to support the moving parts of the bridge, weigh approximately 3 tons. There are 4 of these on each side of the bridge, and all must be replaced. Firstly, the blocks must be prepared for lifting. The lift, already a hazardous one, is made all the more difficult by the bridge's position on the Thames. To ensure the resting blocks are removed with a maximum of safety, specialist lifting equipment is needed, in this case a lift barge. The lift barge is a floating crane used for water-based lifting operations. The weather and tides play a crucial role in the success of the operation. A choppy day increases the challenge and means that the barge operator must use all his skills to lift the blocks from the bridge and onto the barge. This tricky operation was a complete success. Once the old blocks are out of position, the new blocks and control cylinders need to be lifted into place. The cylinders are part of the new bridge control philosophy to ensure that weight is being transferred off the bridge bearings and equally balanced across the 4 resting blocks. With all the blocks in place and the cylinders installed, the hydraulics are connected and new lines housed in protective sleeving. New hydraulic control gauges are fitted to the bulkheads of the resting block area. Cable carriers and grease lines are installed ready for testing of the new support mechanism. A new system designed by LES that will help ensure a longer working life for this moving historic monument. Before work can commence, a permit to work must be issued to ensure that everyone knows who is working and where they are working. The spaces under the bridge where the counterweights are housed are called the bascule chambers. As the bridge raises and lowers, a special locking ram called a pawl helps to secure the bridge into position. These components have become worn over time, and although they're still in working condition, it's imperative that they're replaced and redesigned to take more of the weight of the bridge. The redesign of these components is another example of LES's ability and commitment to quality engineering. In preparation for the commencement of the work, access and safety must be established. The scaffolding is then erected under artificial light in the small working space, making difficult conditions acceptable. Old pipework and hydraulics have to be stripped away, ready for the new lines to be laid. The old components have to be dismantled and slowly raised to the surface using a series of blocks and tackles. Checks are made throughout the process, as the objects are all very heavy and the access and space very cramped. Once the area is clear, then the civil engineering work can begin in earnest. Large sections of solid granite beams have to be cut out to make way for the new equipment. Finally, the civil engineers finish clearing the space and the job of lifting and lowering the new rams can begin. The new rams were constructed in Grimsby by LES Engineering to exact specifications. But there is always a moment of tension as new fittings go into place for the first time. Putting the rams into place takes a full day and night shift. By morning, it's time for some fine adjustments and measurements. Each pair of rams must be exactly aligned. Lasers and traditional plumb lines are used to ensure that everything is square. The new rams have the job of helping to take some of the weight of the bridge off the bridge bearings. Combined with the new resting block mechanism, this should help ensure that the bridge has a longer working lifespan. Final fittings and grease line equipment for the lubrication of the mechanical components are then installed and attached. The pawls are finally ready for their first trial run. With anticipation, an unloaded trial is run and accepted, signalling the end of the pawl refurbishment.